Hello everyone. Today is the week 5 of the course Mathematical Aspects of Biomedical Electronic System Design, and I am the TA for the course. I have given a brief description about myself in the past preceding weeks. That is, I am Chiranjeev Bhaumik. I am currently a Prime Minister Research Fellow in the School of Medical Science and Technology, IIT Kharagpur. I predominantly work in the field of medical image analysis and computational biology. And okay, in the past, let us have a brief description about the course that we have done. In the past week, that is in week 4, we have talked about discrete Fourier transform in general. In the past weeks, we have talked about biomedical signals, we have talked about different types of systems. At the same time, we have talked about various other things like Fourier transforms and its applications in biomedical paradigm. Okay. Today the week 5 is a bit different. Here we will talk about some mathematical concepts which will actually help us in the future to understand the course in a more better manner. So today we'll have a brief introduction about linear algebra in general, and obviously I think you all have seen the week 5 of this course. Basically, we have preliminary concepts about linear algebra in general, a brief description about different types of matrices were given. There was a description of different types of matrix like square matrix, like symmetric matrix, anti-symmetric matrix, and also various complex matrices. Okay. After studying the different types of matrices in the course, there was a brief description about matrix multiplication, inverse of the matrix. At the same time, we have studied about various types of linearly independent as well as linearly dependent vectors and also bases. These were the things that were actually described in the linear algebra 1 lecture, and also there were a couple of other lectures on the device fabrication part. But as in this course, as or in this tutorial, in the live session, we will be mainly solving numerical problems. So this will be the things that we will be doing today. Okay. So basically we will be solving some simple numericals, as if anyone, I think you have seen the lecture number as the lecture in week 5. There was a very brief description of linear algebra, so questions will be related to the topics that were actually done in that class. In the next sessions, similar type of numericals on rank of the matrix, etc., will be solved when it will be done in the class. That's in the week 6 and week 7. Okay, today the lecture is quite simple, and the numericals are also quite familiar and simple. So let us consider, we have this is the first problem to us. It's a very simple problem. The problem actually gets its idea from the concept of the multiplication of matrix. The question is, if A is any matrix, it is given that A is any matrix. The size of the matrix is not given to us, but it is clearly mentioned that for this matrix, AB, that is multiplication of AB and BA, are both defined. We all know that for every matrix, multiplication is not possible. Multiplication between two matrices is only possible if the column of the first matrix is equal to, is the same as the row of the second matrix. For example, there is A into B, that is multiplication of AB, is only possible or existent only when the matrix, the size of the matrix will be in this manner, that the number of column in matrix A is equal to number of columns in row B. The question is, both these matrices are defined. There is multiplication of AB along with BA are both defined. Then our objective or the question is, we have to find the order of matrix B. So this is the question that is given to us. Okay. So as I said, we know that for matrix multiplication, or for two matrices to be multiplied together, the condition is the column of first matrix should be equal to the row of second matrix. So for instance, as it is written AB is defined, let me consider the order of matrix A is plus into n. Plus may be any arbitrary variable. And as the row of the second matrix B should be equal to the column of the first matrix, so the order of B, let it be n into star. Star is any variable. Fine. Now at the same time they are saying BA is also defined. Now for BA to define, the column of B should be equal to row of A. So ultimately what we get, the order of matrix B is n cross n, where n is any variable. Ultimately we understand that B is actually a square matrix. We all know what's a square matrix. A matrix is said to be a square matrix when the number of rows in that matrix is equal to number of columns in that matrix. Fine. So this is the very simple problem. Now let's look into another problem. This problem is also relatively simple. The question is, this question is actually inspired from the assignment problem that you have. I think I would like you to solve the assignment problem. That's actually relatively interesting. I would like you to solve, and if any problem you face in the assignment part, we can discuss it in the next class. Okay, so the second question. Let me consider I have a matrix A, and the matrix A is actually a 2 cross 2 matrix. It's a square matrix, and the content of the matrix is given here 2, 5, 3 and 4. B is also another square matrix, and it's a 2 cross 2 matrix where the content is given as 1, 10, 10 and 11. And our objective is to find A into B transpose. So we have B is equal to this. So B transpose is what? Just change the rows to column and column to rows. So 1, 10, 10, 11, but as the content are same, so what we will get 1, 10, 10, 11. I think everyone understands the concept of transpose of a matrix. Fine. Now, after finding out the transpose of B, now let us obtain the final question that's given to us, that is A into B transpose. So multiplication of this two matrices. So the content of first matrix is 2, 5, 3 and 4, and the content of B transpose is 1, 10, 10 and 11. So multiply this matrix. I think everyone is familiar, but still if anyone don't remember, so we can have a brief revision again. So what you do, you multiply the first element of A into the first element of B. So 2 into 1, which is 2, plus multiply the second element of A to the to 10. That is, here 10 is actually the multiplication. Here 10 is actually the value in A of B in the region A 2 1. I think you can understand what is the meaning of 2 1. The second row, first column. The next is now, so this is actually 2 plus 50. Now what you do next? The next term, that is in the final variable, in the final answer, the next term is actually the content, that is the 2 2, that is second row second column. For this what you do, you multiply 2 into 10 plus 5 into 11. Now for getting the content of A 2 1, that is second row first column, to multiply 3 into 1, that is 3, plus 4 into 10, that's 40, and last is 3 into 10 plus 4 into 11. So this is very much clear. I don't think I need to explain it once. This is a very simple problem. Okay, so there we studied multiplication of matrix. Now another question. Let us consider a matrix A which is having the content as A, B, C and D, and our objective is to find the adjoint of A. So this is a very important thing, because adjoint will actually help us to find the inverse of the matrix. So how to find the adjoint of matrix? So we have a matrix A where the first component is 1 1, a11 is equals to a12 is equals to b, a21 is equals to c, and a22 is equals to d. Now to find the element, to find the value in the a11 component in the adjoint A matrix, what you do, you close the first row. Just you close the first row in A and the first column in A. So what is the component that is left with us? That's D. Now to get the component of A12 in adjoint of A, what you do is you close the first row in A and the second column in A. So what is left with us is C. Now similarly, to get the component A21 in adjoint of A, what you do, you close the first row of A and close the first and close the second. For getting the component A21, what you do is you close the first column of A and second row of A. Then what is left with us is B. Now for getting the last component, that is A 2 comma 2 in adjoint of A, what you do is you close the second column of A and second row of A. So what is left with us is A. And the sign notation is plus minus minus plus. So that's the reason I have written this. And obviously the important thing is we have to transpose this matrix. So after transposing this matrix, we get D minus B minus C. So this is the adjoint vector of this matrix A. So what you can do, you can use this adjoint vector to ultimately find out the inverse of the matrix. We know the inverse of the matrix is equal to, that is A inverse, that is equal to adjoint of A divided by determinant of A. Okay, so this is the thing actually. So next question is, one second. So this is the thing. So let us have another problem, and in this problem we have to find the determinant for this matrix. The determinant for this matrix, that is 1 4 9 4 9 16 and 9 16 25. This is like we have to find the determinant for this matrix. So how will you find out the determinant for this matrix? I think all of us knows how to find out determinant for this matrix. So let us consider row number 1. So we close the row number 1 and close the column number 1. Then what is left with us is 9 cross 25 minus 16 cross 16. Then minus 4. Then you close the second column and the first row. Then you get 4 into 25 minus 9 to 16. Plus you close the third row, third column and the first row, that is plus 9. 4 into 16 minus 9 into 9. So you calculate and you get this value, that is minus 8. Okay. This is another problem. This is a different, not different type, it's more a simple kind of problem. So here also you have to find out the determinant for this matrix. So what you do, you always take the first row, because in the first row the calculation will be simple, because here we have only the first element as some as 2 and others we have 0. I don't know, 0 into multiply anything is actually 0. So what we have, if you find the determinant of the matrix is 2, close the first row, close the first column, then we ultimately have the determinant of the matrix 172 0 2 0 0 6 1. Then what you do, find the determinant for this matrix, take in this matrix, consider also take 1 and then close the first row, close the first column, that's 2 into 1 minus 0. So ultimately we have the determinant for this matrix is equals to 4. Okay, this was relatively a very simple problem that we had. Now let me have another problem. Let me consider that I have a matrix which is equals to A, and this is equals to 1 minus 4 and 1 minus 5. And our objective is to find the inverse of this matrix. So we all know, so inverse of the matrix, that is A, is actually given by adjoint of A divided by determinant of A. So first find out the determinant of the matrix. It is determinant of A, which is actually equals to minus 5 plus 4, and which is equals to minus 1. So this is the determinant of the matrix. Now the adjoint of the matrix. So again, I think you remember how to find the adjoint of this matrix. So what you do is you close the first row, you close the first column, and you get minus 5, then you get 1, 4, 1, then you change the sign. The sign changes less minus, minus, plus. And obviously transpose is very important. So you do transpose, and then so A inverse is what? Adjoint A divided by determinant of it. Determinant is minus 1, so you multiply this negative sign throughout the question, and what you get, this is the actually the answer that you have. That is 5 minus 4, 1 minus 1. Okay, fine. These are the things that we have looked upon. Now let us look into a couple of problems which are a bit different than the traditional one that we have done. Okay, so what is this question? So here it is given that capital X is actually a matrix of size 2 cross 2. It's a square matrix, and the content of this matrix is given here. So the first component is A, then it's 1, then it is minus A square plus A minus 1, and the next component is 1 minus A. And also it is given in the question that capital X square minus capital X plus 1 is equals to 0. And our objective is to find the inverse of X. Okay, we all know the traditional definition of inverse. The inverse of any matrix is actually given by adjoint of that matrix divided by determinant of that matrix. So obviously we could have done or find out the inverse using the traditional method, but it will be a bit complicated and it will take some amount of time. So as we have some kind of equation given to us, so let us try to use this equation and try to solve this problem. The equation is given as follows: capital X square minus X plus I is nothing but it's an identity matrix of the same size of matrix X, that is it's an identity matrix of size 2 cross 2. Okay, so this is very important. So we have actually an identity matrix of size 2 cross 2. Now our objective is to find out the inverse. So what you do, we just multiply X inverse both sides. So obviously 0 into something is obviously 0, so it will be 0 in spite of anything. So you multiply X inverse with this. So X inverse into X square will give us X. X inverse into X will give us I, and X inverse into identity matrix will give us X inverse. So ultimately we have this equation: X minus identity matrix plus X inverse is equals to 0. Or in other words, X inverse is equals to identity matrix minus X. So we see that the problem is actually becoming so simple. We don't have to do much of calculations and obtain the X inverse so easily. So so you subtract this two matrix, the identity matrix from the matrix X. So we have 1 minus A minus 1 A square minus A plus 1 and A. Okay, so this is this type of problem. So it's very important we see that we always don't follow the fundamental way of solving a problem. We have to look into some other things, like we have to look into some other equations. We have to look at the nitty-gritty of the thing and try to solve the problem in different manner. Maybe the solution will be easy and less calculations will be required. Okay, so this is an example which I wanted to show to you. Now it's another question inspired by an assignment, obviously again. It's given that we have a square matrix A and hmm, and our objective is to obtain A minus A transpose. So it is given that A is a square matrix. What is a square matrix? It's already described. The square matrix is one where the number of rows is equal to number of columns. So it can be 1 cross 1, it can be 2 cross 2, it can be 3 cross 2, it can be 4 cross 4 till n cross n, whatever. Okay, this is important. Now, let me consider a simple 2 cross 2 matrix for this example. Let me consider I have A, which is actually a square matrix of size 2 cross 2. This is uh, this is just for my instance. You can obviously consider a matrix of size uh, 3 cross 3. So what you get is if we consider A equal to A, B, C, D, then transpose of A is equals to A, C, B, D. Now you do A minus A transpose, we get 0, B minus C, C minus B, and 0. Okay, this is the thing that we get. And what we get is a diagonal matrix. But don't think that it's a diagonal matrix always. What I want you to do is try to solve the same problem for a 3 cross 3 matrix. And then you see what you get. Okay, that's very important. I want you to solve this problem for a 3 cross 3 matrix and then you see what you get. Because for 2 cross 2 maybe you get a diagonal matrix, but for 3 cross 3 you may get something different. Then ultimately we have to conclude, because when the question is given this way, A is a square matrix and we have to obtain A minus A transpose, that time uh, it should work for all the cases. So that's very important. So it is necessary that it should work for a 2 cross 2 matrix. It should also work for a 3 cross 3 matrix. Here the problem or the solution is actually a diagonal matrix for a 2 cross 2 matrix. But for a 3 cross 3 matrix, the solution can be different. So I want the students to kindly check what's its value for a 3 cross 3 matrix. For 3 cross 3, it will not be a diagonal matrix. I want you to check it. And the solution obviously has to be for a generalized problem, not only for a 2 cross 2 matrix. Fine. This is actually inspired from an assignment. So let me have another problem. This is also inspired from assignment. We have a question. A is equals to A is a matrix where the components are P, Q, Q, and P, and we have another matrix, and or in the question it is well described that we have A square is equals to alpha beta beta alpha. Okay, so this is the thing that we have now. Uh, Now we want what is the value of alpha and beta. So this is the thing that we want to find it out. Okay, so what you do is, as we know, we have a matrix A which is, or in other words, whose component is equal to P, Q, Q, and P. And for example, we know the concept of equality. If two matrices are equal, for example, if two matrices are equal, actually we can equate them. That's very important from the concept of equality of matrix. So what you do is you find out the square of this matrix A. Okay, so find out the square. So PQQ into QP multiplied by PQQP. So what you get? You ultimately get the final matrix. Everyone, I think, knows how to multiply two matrices. Uh, so what you get is P square plus Q square, then 2PQ plus 2PQ, P square plus Q square. This is the thing that you get. Now what you do, as both this is also A square and equation 2 is also A square, we can equate both two matrices by the concept of equality of matrices. And Equality of matrices is if two matrices are equal, each of the components should also be equal. So what you can write, the first element of a square in equation 1, which is equal to p square plus q square, is actually equal to the first component of a square in equation number 2, which is equal to alpha. So we get alpha is equals to p square plus q square. Similarly, the component that is a12 in equation 1 of a square is actually equal to the component a12 of a square in equation number 2. Thus, beta is equals to 2pq. So this is, in thus we have expressed alpha and beta in terms of p and q. So this was the question. This is relatively a simple problem. Now we will go into the other concepts like linear dependent, linear independent, and basis. Okay, so we will go for these problems. So yeah, so so I would like all of you to kindly solve the assignment problem. That's very important actually, because you have to first see the lectures provided by professor, and then you have to solve the problem. In case of any doubt or in case of any queries, you can mail it to me, and my mail id, I think I mentioned the previous class, that's bhowmick1495 at the rate gmail.com. I would like you to solve the assignment problems, any numerical problem, because today I have actually solved similar kind of problem which are done in your assignments, and that will be done throughout uh, till the last of this course. So I am always there to help you. If anyone needs any help, they can ask in the class, or even uh, help, or even send me a mail for any kind of problems. Okay, so this is the thing. So now we will look into two important concepts, that is linear dependence and linear independence, and at the same time we will also look into basis of vectors. So that's very important. We will look into these things, and then after that we will actually wrap up the class. These are the two concepts that's left. Okay, so this is it. This is the question. So the question states that I have three vectors. So vector number 1, which is x1, it is actually a matrix of 1 cross 3 having component of 1, 2 and 2. X2 is also similar, it's a matrix of 1 cross 3 and the components are 2, 1, minus 2. And x3 is also a matrix of 1 cross 3 where the first component is 2, then it's minus 2, comma 1. So we have to check for linear dependent or linear independent. Okay, this is the thing that we have checked, whether these vectors are linearly dependent or linearly independent. So we know from theory that vectors are linearly dependent when it follows the principle of superposition. We can say that is, if x1 can be expressed in terms of some component of x2 plus some component of x3. X1 is equals to ax2 plus bx3, then only it's, and then it should actually solve, or it should actually satisfy the equation, then only it is linearly dependent. Okay, so replace the value of x1, x2 and x3 by the vector that we have, that is 1 2 2 is equals to a into 2 1 2 plus b into 2 minus 2 1. Okay, now from this we can write three equations. That is, the first equation can be 2a plus 2b is equals to 1. I think everyone is clear like how are the equations written. It's relatively very simple. The next equation is a minus 2b is equals to 2, and the third equation is minus 2a plus b is equals to 2. Okay, as we have two variables, that is a and b, two equations are actually enough to solve this and get the value of the constants a and b. So solving this equation 1 and 2, we have A is equals to 1 and B is equals to, actually what we have, B we have equal to minus 1 by 2. Now what you do, you replace the constants A and B in equation number 3. And when you replace this constant, we get in the left hand side that is equals to minus 5 by 2, and the left hand side it's 2. So obviously minus 5 by 2 is not equal to 2. So we can say these vectors are nothing but they are linearly independent vectors. So this is very important. These two terms, this concept that is of linear dependence and linear independence are actually very vital and very important for this course in general. So this was the first problem, and where we got these vectors are linearly independent. Okay. Now let me have another problem, and the question is actually given in as question number 11. So here again, let me consider I have three vectors, that is x1, x2 and x3, and x1 is again a so what we have, x1 is again a vector or an array of 1 cross 3 which have the components of 1 2 3. X2 is a vector of 1 cross 3 which has component of 3 minus 2 and 11, and x3 is another vector of 1 cross 3 which have elements of 1 minus 6 and 5. And what's the objective? The objective is to check whether these vectors are linearly independent or linearly dependent. So I would like you or the students to kindly solve this problem on your own. The question, obviously, the question is inspired from the question number 10, and you have to follow the same procedure. Okay, so what you have to do for checking out whether they're linearly independent or not. So let's consider an equation that is the linearity, that is x1 is equal to a x2 plus b x3. Then as you have as it's an array of 1 cross 3, so you will have three equations. So you will consider any two of the equation and then find out the constants a and b and replace the value of the constant in the third equation. Then you see if the left hand side is equal to right hand side, then it will be linearly independent vectors. Otherwise, the vectors will be linearly dependent. Okay, so this is so we'll solve one more problem. I think it's clear. I think everyone understood like what I wanted to do basically. So okay, so this is another problem that we that I want you to solve, that I have done. Okay. Okay, before doing this problem, like I have, I want to give you, just as I said, I wanted to give you a couple of suggestions and couple of things I actually wanted to discuss. Actually, if any of you has a problem or didn't and has problem with any of the topics even in the preceding weeks, that is in week 1 2 3 or 4, I am actually happy to solve those doubts. You can all obviously tell in the class, obviously the number of people joining this class extremely low, so I do not know like how will I meet you, but still I would like you to tell me if you find any kind of problem, if you have any kind of difficulties in solving your assignment, or you didn't understand any particular concept. I am actually eager to take the topic again in the class. I will explain you what, I will tell you whatever you want. At the same time, I can even solve a couple of problems which maybe you find it some where you find some difficulties. So okay, so you can either, as I already said to you, I have already given the email ID. You can even mail me there if you find any kind of problems. The problems particularly don't have to be from the present week. It can also be from the past weeks. Maybe some critical concepts you didn't understand. I would like you to kindly get back to me. I am ready. I will actually be very happy to take those topics in the next class. Okay, so these are the couple of things that actually I wanted to tell you all. So okay, let's move into the last problem. So what is the last problem that we have? We have to understand that question is in this manner. Verify vectors u, v, w form a basis in R3. Okay. So there are three variables or three vectors in particular, u, v and w. So u is also again a 1 cross 3, v is also 1 cross 3 and w is 1 cross 3. And the content of u is 0, 1, minus 1 and content of v is minus 1, 0, minus 1 and w is 3, 1, comma 3. For basis, for example, for forming basis in R3, these vectors has to be linearly independent. Or in other words, the determinant should be not equal to 0. Determinant should not be equal to 0. So obviously at the same time you can find linear independent and linear dependence by the method described earlier. So this is another method. If determinant not equal to 0, also we can say that these vectors are linearly independent. So find the determinant of this vector. So it's 0, 1, minus 1, minus 1, 0, minus 1, 3, 1, 3. So I know that all of you know how to find determinant. So what you do is minus 1 into 0 plus 1, minus 1 into minus 1, and then what you get actually is 1, which is not equal to 0, and so a linearly independent vector, and thus it forms a basis. Okay, fine. So these are the things that I wanted to describe. So I think my screen is visible. uh, uh, these are the assignment problems for week number 5. Wait, I will just show it to you. I think you have all have seen it. So these are some very simple problems on device fabrication. I think I should not. This is a very simple problem. So you have to understand. Consider the following statement for real numbers m and n and matrices p and q with equal size and select the correct option. So you all understand what is associativity and distributivity. मतलब associative property of matrices and distributive property of matrices, and using these properties you have to solve this problem. So next is, if A is a square matrix, then so I think you all know what's a square matrix. Similar type of problems are actually solved in the tutorial today, so kindly look into it. Now, this is another problem which is very simple. For a square matrix A, we have A given the component equal to something, and we have another A square where the component is given something. So we have to find the correct relation. This is a kindly do it. This is a very simple one. You first just find out A square and then equate matrix by the concept of equality of matrices. Okay, so what the next problem is, we have A, which is a matrix of 2 cross 3, and we have B, which is a matrix of 3 cross 2. Okay, we have to find out A into B transpose. So when you do B transpose with the matrix which is of 3 comma 2 will become 2 comma 3, and then what we have, what is A is a matrix of actually 2 comma 3. So ultimately you have to find out the matrices 2 comma 3, and then you have to just find out the multiplication of matrices. Consider the following two statements for the vector space R cube and select the correct option. So we have three vectors and then one, and then you have to see how bases, and then you have to check for bases and linear independence, and then ultimately you have to give the solution. This is a very you have to check this problem. This is similar type of problems are actually described in the class today. Fine. So then you have couple of problems on the device acquisition part. These are like EEG acquisition device aims to record biopotential for the following different discharges. Which among the following can be the best value of the sampling frequency for the acquisition mode? See, please, I would like you to solve this problem. It's a very simple one. I can't solve it directly because that's not allowed. So please try to understand if I can solve this problem obviously in the next class. But I think all of you know what is an EEG. Obviously, this has no relation to the question, but I'm just asking. I think all of you knows what is an EEG. EEG is nothing but electroencephalogram, which measures the electrical activity of the brain. And EEG actually has wide applications. It can be used to determine various kind of brain disorders, right from epilepsy to monitor strokes in patients. So this is actually wide range of applications. So this is a very important acquisition device, and EEG research is actually in a very full grown stage, and people throughout the world are working on EEG analysis and EEG device construction. So these are the things which I wanted to say to you. So we have so these are some other questions. So these are like this is a very simple one line problem. So we have to consider the following. Achha, these are the things I think is easy. I don't have to describe. I don't have to go deep into it. Okay. So next is the week 6. That this just let us have a brief description about it. If we have time. Then in the next class, we will actually solve similar kind of problem. So next class, what actually I am planning. If you have any ideas, you can suggest. Next class I'm planning, I will actually explain to you Beer-Lambert law. So I understand. Then we'll have a brief understanding why it's so important in biooptics as in general, what is its concept, what are its implications, what does it mean, solve a couple of problem of in Beer-Lambert law, which is actually very vital and very important equation for biooptics in general. Okay, then obviously we will continue with linear algebra. We have done very simple linear algebra today. We have solved, we have basically talked about matrix manipulation in general, talked about determinant, talked about inverse the matrix. Next they will talk about another very important concept of matrix, which is the rank of the matrix. That's actually very important, very vital, and it's very interesting in general. Okay, so we'll talk about rank of the matrix. So these are the questions that you have of rank. Then we will talk about some different types of matrix, solve a couple of problem. Then we will talk about singular matrix. We'll talk about characteristic equation. Maybe we can talk about eigenvalues and eigenvectors. You have to understand what it is meaning, how to obtain the eigenvalues, what does eigenvalue signify. So these are all these things that we actually I'm thinking of doing in the next class. So this, and then maybe we'll solve a couple of problem in finding out eigenvalues and eigenvectors. Okay, and these are some very simple biological question, and that too we can, I think that you can manage. My class will mainly focus on solving some kind of numerical problems. Okay, so these are the things that I actually wanted to do in the next class. So okay, I think we can wrap up the class for today. If anyone has any questions, can I kindly ask? Okay, I think no questions. Then we can end the session. Okay, thank you everyone.